Chemistry is awesome.
Alright, Assalamualaikum warahmatullahi wabarakatuh and salam sejahtera. So welcome back to this channel. Okay, so in today's lesson, we are going to discuss the third subtopic for this chapter 1. Okay, stoichiometry. So in the first part of this 1.3, you are required to learn how to write and balance chemical equation by inspection method. And second, you are going to learn how to balance, how to write, and also how to balance redox equation through ion electron method. But for this lesson, I'm going to just focus on the first part, which is how to write and balance the chemical equation through inspection method. Alright guys, so to start this lesson, I'm going to use one example. So here I'm going to use octane. Do you know what is octane? Octane actually is a hydrocarbon. When we say hydrocarbon, what is hydrocarbon compound? Compound that contains only carbon and hydrogen. And octane is an alkene with a molecular formula C8H18. Okay, and octane is a component of gasoline, or here in our country it's known as petrol. A component of gasoline or petrol. Since octane is a component of gasoline and petrol, okay, of course, octane is highly flammable, and also they are highly volatile. Right now we are going to have a look at what happened to octane when they are combusted. So since octane is an alkene, it's a hydrocarbon, all hydrocarbons, when they are completely combusted, they will be converted into carbon dioxide and water. The question here is how to write an equation that shows the combustion of octane. And here I'm not just asking you to write an equation, actually how to write a balanced equation to show this combustion of octane. So no worries guys, so here in this video I'm going to explain to you stepwise or step by step. Okay, I will guide you how to write a balanced chemical equation using this combustion of octane as the example. Okay, how to balance a chemical equation. Alright, so the first step is, what you're going to do is, we are going to convert the statement into a skeleton equation. Okay, for example, we know that octane is a hydrocarbon. So when this hydrocarbon is combusted, and as usual, combustion requires oxygen gas. So that's why in this combustion of octane react with oxygen to produce carbon dioxide and water. So let's convert this statement into a skeleton equation. So the skeleton equation for this reaction will look like this. Okay, so we have octane, we have oxygen, so both of these are the reactants. Okay, and the products are carbon dioxide and water. Okay, and of course to balance an equation requires the coefficient. So right now we do not know yet what are the coefficients for each of these components in this equation. Okay, so this is the first step. Right, the second step, what should we do is, we need to balance the number of atoms, or specifically we need to balance all the atoms in the equation in terms of their moles, number of moles of each atom in the equation. Okay, so how to balance them? So first of all, we are going to start with the most complex substance. So in this case, the most complex substance is octane itself. Since octane has 8 carbon atoms and 18 hydrogen atoms, if we compare with other components such as oxygen, carbon dioxide and water, so octane is far more complex. So we are going to start with this octane. Right. Okay, so to begin with, we are always going to start with this more complex substance. We will assign this octane as 1 mole. Okay, if octane here is 1 mole, means 1 mole of octane contains 8 mole of carbon atoms. So here we have carbon dioxide. So since in octane here there are 8 mole of carbon atom, so that's why we need to put at the front here of this carbon dioxide 8 moles of carbon dioxide, because we want to balance the number of carbon atom in carbon dioxide and in octane. So 8 carbon atoms here and 8 mole of carbon atoms in carbon dioxide. Right. And the next is we are going to balance hydrogen. Okay, so here in this octane there are 18 moles of hydrogen atom in 1 mole of octane. So that's why over here at water here we need to multiply this H2 by 9, because 9 times 2 is 18. So we have 18 hydrogen on the left side, 18 hydrogen on the right side. Okay, so the only component left now is oxygen. So if we total up the number of oxygen atoms on the right side, so there are 8 times 2 here, so here is 16, so 9, so 16 plus 9 is how many? Yes, 25. Okay, 25 moles of oxygen atoms on the right side. However, if you look properly, on the reactant side here, the oxygen that we are using is oxygen gas, and the molecular formula of oxygen gas is O2. So if we write 25 here, so 25 times 2 should be 50. So of course the equation will not balance. So that's why what we need to do is 25 divided by 2, because we want to cancel these 2 and 2 here. So we are going to get 25 mole of oxygen. Okay guys, so remember, for a more complicated equation, always assign coefficient 1 to the most complex substance, and later we are going to use a symbolic coefficient such as A, B or C or etc. to other substances. Okay, let's move on to the third step. Okay, in the third step or step 3, we are going to adjust the coefficients. We are going to adjust the coefficients. Okay, so this is the previous from previous step. Just now we have already balanced the number of atoms in the equation. Okay, so normally in any chemical equation, a balanced chemical equation, we always prefer the smallest whole number coefficient. If we look at this equation, okay, all of the components in this equation, okay, are not in whole number, especially for oxygen. So what should we do is, we are going to multiply the whole equation by 2, because we want to convert this 25 over 2, this fraction here, into a whole number. And what will happen to this equation, we are going to get, okay, 1 times 2, we are going to get 2, 25 over 2 times 2, we are going to get 25, okay, and 8 times 2, we're going to get 16, and 9 times 2, 18. So remember, whenever we multiply the whole equation, all of the coefficients in the equation will multiply with the same number. Okay, and what do we get here? We have 2 moles of octane, 25 moles of oxygen, 16 moles of carbon dioxide, and 18 moles of water. So let's say if this equation can be simplified, yes, we can simplify this equation. But for this case, this is the most simplified balance equation for this equation. So we could not divide by another number because this is the simplest one. Okay, step 4. So in step 4, we are going to do the checking. Okay, we're going to check whether all of the atoms on the left side of the equation or on the right side of the equation is balanced or not. So how to make this how to do this checking, right? So based on the balance equation just now, okay, we're going to start with the left side or the reactant side. So on the reactant side, okay, there are 16 carbon, 2 times 8, okay, 16 carbon, 36 hydrogen, 18 times 2, 36 hydrogen, and we have 25 times 2, 50 oxygen atoms. Okay, so those are the elements on the left side or the reactant side. Now let's check on the right side or the product side. Okay, on the right side we have 16 carbon. Yes, 16 carbon, same as the left side, 16 carbon also. And then we have 36 hydrogen. 18 times 2 is 36. On the left side also 36. So therefore hydrogen atoms are balanced on both sides. Okay, and 16 times 2, 32 plus 18 is 50. So means that the oxygen atoms are also balanced on the right side and the left side. 50 oxygen atoms. So the equation is balanced. Good. All right. Okay, so this is what we call as in step 4 we must check whether the both sides on both sides to make sure that both sides are balanced. Okay, and the final step is step 5. So in step 5 we are going to specify the states of matter, whether the components in the equation, whether they are solid, liquid, gaseous state or aqueous state. So in this case, since octane is in liquid form, so we're going to put liquid, and oxygen gas, carbon dioxide gas, and water vapor also in a gaseous state. So we're going to write the states of matter, okay, for each of the components in the equation. Okay, and lastly, just a reminder to all of you, remember, a coefficient operates on all atoms in the formula that follow it. Okay, second, whenever we are trying to balance an equation, remember, please do not ever alter the chemical formulas. For example, octane is C8H18. Do not alter the formula, or else they will turn into other compound. Okay, remember. And the third one is, please do not add other reactants or other products to balance equation. For example, if we look back at the equation that we are discussing just now, okay, so the reactants are just octane and oxygen, okay, and then on the products side we have carbon dioxide and water. So do not add other reactants or other products to balance equation. So whenever we are doing this balancing, just use all of the components given in the equation. Okay, and lastly, remember, a balanced equation remains balanced even if you multiply all the coefficients by the same number. Alright guys, so that's all for this lesson. So in the next lesson, we are going to have a look at how to write and also how to balance a redox reaction. Okay, that's all from me. Thank you. Bye.